ladies and gentlemen.
Sorry, I'm Scouts via Sana, and I'm also here with Scouts via Todd.
Hello.
And tonight we will be presenting with you all the Arrow of Light and Webelos Den Meeting, and today we're going to focus on the Adventures in Science.
So thank you all for joining us. Normally we'd wait a couple minutes to get started, but since we're running a couple minutes behind, we're going to get right into it. So to start things off, Anna, would you like to lead us in the Pledge of Allegiance?
I sure would.
If you're in uniform, Scout sign and salute. If not, hand over heart. I pledge allegiance
to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. 2.
Go ahead and do.
Now will you follow me with the Scout Oath and the Scout Law? We'll start with the oath. On my honor, I will do my best to do my duty to God and my country, to obey the Scout Law, to help other people at all times, to keep myself physically strong, mentally awake, and morally straight. A Scout is trustworthy, loyal, helpful, friendly, courteous, kind, obedient, cheerful, thrifty, brave, clean, and reverent. 2.
Well, thank you very much, Anna, for leading us in those. Today, as she said earlier, we are going to be going over a Webelos Adventure in Science. We're going to do 3 requirements. Number 2, you're going to have to do partially on your own. So number 1 is an experiment, an experiment and a fair test to compare possible explanations. We'll draw a picture of a fair test and show what you need to do to test a fertilized effect on a plant. Next, and this one you'll have to do partially on your own, is visit a museum, a college, a laboratory, an observatory, a zoo, or an aquarium on your own, and ask 3 questions ahead of time and prepare them and send those to the scientists. So what we're going to do is we'll explain a little bit later on how we're going to allow you to do that. And third, we're going to do 4 parts of section 3. First, Anna, she will be working on carrying out the experiment that we talked about in requirement 1. Next, she'll be carrying out that same experiment with a different independent variable, and we'll explain what that is a little bit later. And then we'll report on what changes the variable had. And then I will be doing, with adult assistance, we'll be exploring safe chemical reactions with household materials. We'll use 2 substances and observe what happens to the amounts that, as the reaction as the amounts increase. And then we will also explore the properties of motion on a playground, slightly adjusted. We'll be doing that here, but don't worry, we'll get through it. And we'll look at how the weight of a coin versus a person would affect how fast they slide down a slide. Our slide's going to be a paper towel roll, so go ahead and have those ready. And we'll design a fair test to answer these questions. So Anna, what will you need today to be able to do your experiments?
So what I will need today is warm water, jars, measuring spoons, some stirring sticks, pepper, salt. In this case, I'm going to use Epsom salt, laundry powder, and dish soap.
Excellent.
Cool.
And then I will be working with vinegar, oil, baking soda, water, and then I'll need a couple glasses. And then I also have a spoon and a bowl just to help measure some of the experiment. And then I highly recommend that you have paper towels. One thing to note, and we'll talk about this a couple times, make sure that we're not eating anything that we're working with today or getting any on ourselves. None of this is harmful, but we'd just rather be safe with what we're doing. Okay? Excellent. So first, we're going to explain what a fair test is. Anna's going to be helping out with some of the drawing and showing what's going on, and I'll kind of explain what a fair test is.
Awesome. All right.
So a fair test is a test which controls all but one variable when attempting to answer a scientific question. So we're only changing one thing in each of the different tests, and we're going to try and keep those constant otherwise. So for Anna's, she'll be keeping the water constant in the glasses, and I believe she'll also be keeping the soap constant, correct?
Yes.
Okay. And then would you mind showing us the diagram of the FAIR test?
So in reference to the requirement number 1, it talks about fertilizer and the different types of fertilizers. So we designed a FAIR test that could test that. So in each one of these is a pot that represents a different type of soil. So we have rocks, sand, dirt, and potting soil. Potting soil is going to be our constant. We expect that the soil here will provide good nutrients to grow. Everything else will be the same. We will give them all the same amount of water, the same amount of sunlight, the same amount of love and attention. And then as the days and weeks progress, we'll document to see which one of the soils the plants grew the best in. And speaking of FAIR test, in all scientific methods, we have a specific method that we do. When we create our experiment, we use this scientific method. We ask a question, what happens if? And then we create a hypothesis based upon what our question was. So in the instance of our FAIR test with the fertilizer, we ask the question, what happens if the soils are different for the plants? And we form a hypothesis. I think the soil will affect the growth of each of the individual plants. From there, we ask our question. Now we got to test our hypothesis after we create our hypothesis. So the experiment in itself, that's the test. And then from the test, we make our observations. And then our observations, we take note of what it is, and we conclude or create conclusions.
That's awesome, Anna. So yes, we'll definitely be using the FAIR test approach to this, as well as a scientific method. Just one more time to reiterate, the scientific method is 6 parts. The purpose or question, we're going to ask a question. We're going to research what we're doing. We're going to put forward a hypothesis, what you think will happen. We're going to run the experiment and then see what happens. We're going to look over what's happened, and then we'll have a conclusion to see if our hypothesis was right. So right now, we're going to take a minute pause. If there are any questions, now would be a great time to go ahead in the chat box below, and we'll get those up and see if there's anybody asking us any questions or if you need some help. If you don't have any questions, this would be a great time to get any resources together so that you can do the experiments with us or right after this. So feel free to take a second and we'll answer any questions that there might be.
So we don't have any questions yet, but we'll keep watching. But we have a hello from Aaron and Amber. They're here with us today. And Shauna and Christina. So we'll just give them a second to see if anybody has any questions. But if not, we can head on to the next portion.
Excellent.
Oh, Aaron Peck Jr. asked, what did you need? So in the description of this post, there's a list of everything you're going to need for the experiments that are taking place today. So you can just go on up to the top and click on see more, and it'll have the whole list for you.
Absolutely. And we want to thank everyone for tuning in today. We really do appreciate the opportunity to do some really cool experiments in front of you. And then right before we get started, because we were just talking about flowers and plants, I did have a little flower joke. Anna, would you be so good as to humor me with a response?
Absolutely.
What did the big flower say to the little flower?
I don't know. What did he say?
Hi, bud.
Ah!
Yeah, flower bud. It's pretty funny. So that leads us to our second part of our Webelos Science Adventure. So we went through what a fair test is, and then we talked about the scientific method, which is what we'll be doing in our experiments today. But the second requirement actually makes you go out into the field and visit either a museum, a college, a laboratory, zoo, or an aquarium. Now, I realize that's really difficult right now, seeing as we're all at home, we're watching live streams, we're not really able to get out and be around people right now. So in order to change that and be able to do something different, we've included a link to 20 different museums that you can go to. Museums, libraries, zoos, you can do a virtual tour of them and check those out in the link down below. Those are going to be great, but in order to complete this requirement, make sure that you have 3 questions ready. You can either send those in or give those to your AKLA or your adult leader or parent or guardian that can help you get those to those individuals. So have some questions ready, think about what you want to talk about, and get those together. So feel free to take a second and do that, and we'll give one more bad joke. Anna, do you have one, or do you want me to give another joke? Okay. So Anna, why are fish so smart?
Why are they so smart?
Because they live in schools. Oh,
Ah.
terrible. But with that, we're going to bring it back. Brittany, are there any questions right now?
From what I can see, there's a lot of hellos. Martin from Pack 636 is here with us.
Awesome. Hello.
1 second, it's just loading. And I think that's all right now.
That's okay.
So I'll stop you if there's a question in a second.
Excellent. Okay, one more joke, and then we're going to start the fun part, the experiments. Okay. So, what do you call cheese that's not yours?
I don't know. What do you call cheese that's not yours?
Nacho cheese.
Ah.
Yeah. So now that we've gotten a couple bad jokes out of the way, let's go ahead and get started on our experiments. So our first one is going to be run by your very own Anna. And she's going to be going over all the things that you'll need to do, as well as you can watch what she's doing in the experiment. So go ahead and tune in and take a look at what her hands are going to be doing.
Hi, everybody. So today we're going to test different types of water and different materials in those water. For instance, the question is there a difference between soft and hard water? And how we're going to test that is we're going to have a control, which will be the one with just dish soap, one with laundry soap and dish soap, and one with Epsom salts. So as we go through, I'm going to explain everything I'm doing. So the first step that we're going to do, and I already prepped this, is we're going to get some warm water.
Hey, Anna.
Yes?
Somebody wants to know if borax works for laundry powder.
No, it should be laundry powder, but I think in this instance, it might work if that's what you have on hand. You can give it a shot. If not, that's okay. That's why we test things. We try them out. We do our best. So.
Thank you. That's awesome.
I'm sorry?
That's awesome. Thank you.
Oh, you're more than welcome. First thing we're going to do is we're going to fill about as evenly as we can, a jar or a glass. So I'm just going to go ahead. There's lines on here. I'm going to fill it right above the second line. There's a good glare on that. All right. And then we're going to do that with all of our glasses. All right, I filled that one a little too much. That's okay. We're just going to pour it on in here until it's about even. Or we could just add more on the other one. That's right. All right, that looks pretty good. And then we're going to fill this one up with our warm water. It's important that it's warm water because otherwise it's not going to have the same effect, and you'll see why. All right. Beautiful, beautiful. The next step is we're going to take our measuring spoon, we have a teaspoon, and I'm going to use just the one side, and we're going to take dish soap. This is just any old dish soap that you would use to wash your dishes in the sink. And you're going to fill this up about a teaspoon each, and it's going to go in all three of them. So mix it in, and it's kind of cool that it's colored, so you'll get to see a little bit more as we go through.
Make sure to see the difference between a teaspoon and a tablespoon.
Yes, this is a teaspoon. This is a tablespoon. All right, get in there. Go for it. All right. The reason that I'm measuring out everything is I want it to be as consistent as possible. Remember back when we talked about the fair test? We want the experiment to be fair, so we're going to test everything as equally as possible. So I'm going to set this here because we'll use this later because it's got two sides. We'll use it later. So now,
before you get started, what do you think, what's your hypothesis for this? What do you think is going to happen?
My hypothesis is that each one of these the water is going to look different, and maybe perhaps when I put some dirt in it, it may change the effect of where the dirt goes.
Oh, okay. Very cool.
I think that the laundry soap is going to make the dirt go completely away. Let's see if that's the case. So next I'm going to take this spoon. I'm going to use the back end of it. So you could probably use like a knife or a spatula or something that fits in your glass. And I'm just going to mix these up, all of them. Mix, 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 mix. And this is why we want to make sure it's warm water, because you can see the bubbles will start to form. And we're going to do that with all of them. We're going to mix, 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 mix. And this is why we also want it to be about even with water. This is the only time that I'm going to be putting the same one in all three of them, because right now all three of them have the same ingredients. We do not want to mix sticks or anything else. I got a little soap on me. Because that will change the effect of the experiment. We want to make sure it's good and fair. All right. So as we're going through, our next step is we're going to add our salt and our laundry soap into one of each of the jars. So this one here will remain our constant. Oops, our constant. So it only has dish soap and water. So we can see the differences between just dish soap and water. All right. So we're going to grab our Epsom salts.
And you can see all three currently have bubbles in them, right, Anna?
Yeah.
Hey, Anna, can you scoot your jars over a little tighter? They can't see the one jar at all. Yeah, a little bit farther. Yeah.
Beautiful.
There we go.
Thank
Much
you.
better.
All right. And if you don't have Epsom salt, regular salt will work fine. So fill it up, 1 tablespoon. We're going to put it in.
One of these.
Put that over there. And then we're going to take, I just have a random good old takeout chopstick. And I'm just going to mix it up a little bit. So you can see there's still some bubbles in here. But now the water's gotten really murky. I'll pull it up. So it's kind of cool. And then next up, we're going to wash our spoon off, make sure it's nice and clean. So there's nothing else on it. And we're going to take our laundry powder, or if you have borax, let's see if the borax works the same way. We're going to take this again, and we're going to put 1 tablespoon in there. So again, 1 tablespoon. We're going to put it not in this one. We're going to put it in this one. Put that in. Put our powder away. Grab a new stick, and we're going to mix this in. Okay, lots of bubbles, all the bubbles. All the bubbles. All right, put that aside.
Gary asked, if you use the same spoon for all of them, that would be cross-contamination, right? That's
correct. That's why I took this tablespoon and I washed it out, wiped it out real good to make sure that there was no salt going into the laundry soap. And if you did laundry soap first, vice versa. But this one will have nothing, no extra ingredients quite yet.
That's a really good question.
That was a great question. This so you guys can see is what the constant looks like. This is the Epsom salt, or the salt. And you can see there's not really very many bubbles left on top of here. And then our laundry soap, there's some thick bubbles up in here. But you can see how the particles are all floating around. This is why the laundry soap is important. Cool. Cool, cool, cool. So now we are going to see what happens when dirt is added. So I'm gonna make another jar. This one is just warm water right now. I already pre-measured it. I'm gonna make another jar with soap so we can see the difference between our constant soap water with the soap and water with the dirt, soap, salt and water with the dirt, soap, laundry soap, and the dirt. So we can see all the differences. All right, so we're just gonna put one more tablespoon in here. Mix it in. Try not to make a mess. If you do, we were prepared. We covered the table with a placemat. All right, so we have our bubbles. Excellent. So we're gonna set this one to the side. We'll come back to it, but I can only really get 3 in the frame. Next up is our powder, or I'm sorry, our pepper. So this is just ground pepper, nothing special, nothing fancy about it. But you remember our teaspoon? We're gonna go ahead and we're gonna dip in 1 teaspoon of pepper, and we're gonna put it into each of our 3. So 1, ready? Woo! Here we go. All right. You see what happens when this is just the dish soap. Look at how the pepper spread along the top, and it went all the way through it really quick. And it's starting to settle. We'll look at it again after we see the other ones. All right. Next up is the Epsom salts, or the salt. We're going to do it again. We're going to do 1 teaspoon of pepper. It doesn't have to be exactly 1 teaspoon, but it should be the equal amount in each of them. So we're gonna go ahead and we're gonna dump it in. All right, so it looks like it's spread all out through at the top, but it is slowly trickling down. I don't know if you guys can see that as well as I can. It's really murky, so you can't even see through it. But it's slowly working its way down, and a lot of it is just sitting right on top. All right, last but not least is our laundry soap. So we're gonna take, again, 1 teaspoon. And if you don't have a teaspoon, just like a regular spoon, make sure it's just the even amount in all of them. 1 teaspoon into our laundry. All right. So it looks like top. And it is just going straight to the bottom. So the pepper in this is representing dirt. So when we think about washing dishes, washing ourselves in like a bath with like hard water, and washing our clothes, think of what this would look like, or think what that looks like. All right, so now we're gonna compare them all to our constant. Remember that this is our constant with just the dish soap. So our dish soap constant versus our pepper dish soap. Most of it is settled to the bottom. There's still a little bit lingering on top, but most of it is all collected together. All right. Next up, we have our salt concoction. So if you look, a lot of it settled to the bottom. However, it's still on top, and the color has pushed throughout. So instead of being white murky, now it's really dark and brown and murky. All right, and then last up is our laundry soap. So you can see what it looks like on top. And then in comparison, so it's like still slowly moving its way down. I don't know how well you can see it, but if you're doing it at home, you can see that there's different layers. So it's bubble layer, and then like a clear layer, and then dirt layer, and then pepper right along the bottom. But it's slowly, all the pepper's making its way down. All right. Awesome. Any questions about what we've done so far?
Nothing right now. Just lots of likes and lots of cool.
Awesome.
Cool. And wows.
Wow. Yes. All right. So if we look at this and we think about the different substances in situations where we're like washing our clothes, when we want to wash our clothes, we can see that the soap, everything just sinks right to the bottom. So that's probably really nice when we're trying to get stains out of our shirts or our pants or whatnot. It just pulls it all out and it sends the dirt to one place. And then when we're washing ourselves or we're soaking, we can see how the salt really sets together, because from the get-go, we weren't even able to see through it. So there's a lot going on there. And you can see how the pepper or the dirt really gets stuck in there. And then with our dish soap, we can see that it just kind of all goes straight to the bottom. And I bet if we set it for a little bit longer, we could watch all of everything settle to the bottom. And how that's different than just our constant, which is the soap and water. We can see there's no dirt in our soap and water. Ta-da! Excellent. So in conclusion, I think my hypothesis is right, that each of them were a little bit different. And it's really cool to see how we can figure out how to clean things out from home. Cool.
Awesome. Way to go, Anna.
Thank you. Thank you. I'll be here all week.
Okay.
Are there any questions, Brittany?
There are not any questions, but we have lots of people here. So.
All right. We can come back and look at, after Mr. Todd's going to go for a little bit, we can come back and look at these in a minute or two.
That would be great.
Cool.
So while we're on that, I think we're going to continue this. Since there are not any questions, I think I'll go ahead and start my experiment. So remember, this is with adult assistance, and remember that none of this is for drinking or eating. Very important. Okay, so we're going to explore safe chemical reactions with household materials. We're going to use two subjects for two different experiments. We're going to use oil and water, and then we're going to do vinegar and baking soda. So we're going to do the oil and water first. But while we're doing this, we want to see what kind of reactions are created, and we want to see if having more increases the reaction. So I think that for the oil and water, I think they're going to mix together, but we'll have to take a look and see. So the first one, we're going to have our clean glass right here. We're going to put it inside of our bowl just in case. I don't know what kind of reactions might happen. Then we're going to take our oil, and we're going.
You're going to want to move it over just a tad bit more.
Yep. Going to move it up so that everybody can see it. Sorry about that.
There we go.
So next, we're going to take our oil. We're going to pour a little bit of oil into the bottom of the glass, just like that. So now everyone can see the oil in there. Next, we're going to take our water in my handy Scout water bottle that goes with me everywhere. We're going to pour some water in there. We're going to mix it around and see what happens. Wow. Okay, it looks like, for those of you that can see it, it looks like it's separated. The oil is kind of sitting on top of the water. So initially, it looks like my hypothesis might have been wrong, but we'll test it again. We'll see if.
Hey, Todd, hold it up to your face one, because we can see it better.
Okay.
Closer to the screen.
How's that look?
Yeah, we can see the separation.
Okay, yeah, you can see that the oil, which is yellowish, is sitting on top of the water on bottom. So let's try that again. This time, we're going to do it in the oil. Still, the oil is on bottom, so nothing is changing. that's the fair test. We're doing it exactly the same. And then we're dumping water into it. We're just doing more this time around, okay? So we're gonna give it a good shake. But it looks like it's gonna be the exact same. So we're gonna get the same result. I'm gonna show everyone in the camera again. As you can see, the oil is on top and the water's on bottom. So it's okay, my hypothesis was wrong, but that's exciting to see that even a small and a larger version of the same experiment, changing the amounts didn't affect what happened. Cool. So that one wasn't quite as exciting, but that's okay. It's cool to see that they separated. And you can see here again, I'll show it one more time, that both are still separated. So the oil's going to sit on top. So that's kind of cool. Any questions, Brittany? Shouldn't be too hard. Shouldn't be making a mess, but make sure that if you are making a mess, that we have some paper towels to clean up, okay?
Looks like nothing too much, just some agreeing with your hypothesis, and then they said, yeah, wasn't quite the right one.
That's okay, though. Yeah. So now we're going to move on to our second experiment. This one, we're going to need baking soda, and we're going to need our vinegar. Okay? So for this one, we're going to pour the vinegar in first into our clean cup. A little bit in there so that we can save a lot for our second reaction. Okay? If there is a reaction. So my hypothesis for this, I think we're going to get maybe another separation. What do you guys think? I think we'll separate again, similar to oil and water. Go ahead and comment down below and see if the same thing happens. So I got a little bit less than a teaspoon. So we're going to pour that in.
Hey, Anna, can you turn off your one camera so we can focus it in on the other experiment?
Wow. So we got quite a bit of fizz, as you can see. That was pretty cool. So that was a lot different than our first reaction. It fizzed big, and then it's kind of tapered off a little bit. So pretty big fizz, almost like a really bubbly soda. So don't drink it. It doesn't smell good. You probably won't enjoy it, but that was pretty cool. It was neat to see. So definitely different than the oil and water. It didn't separate. It expanded and released some sort of gas. So that's exciting. So let's try it on a little bit bigger of a scale. I'm going to do the larger cup of vinegar, and we're going to try and do a full thing of baking soda. So what do you think is going to happen? Do you think it'll be the same? I don't know. We're going to find out. I think it'll be pretty similar, maybe a little bit bigger. So let's go ahead and pour this in.
Aaron thought it was going to come, so that's what their prediction is.
That was quite a bit bigger and was pretty fun to do. So I highly recommend you do this at home with your parents' permission and with their supervision. So feel free to check that out. It was a nice big pop. As you can see, it overflowed a good amount into our bowl. So that's pretty cool to see. It was a bigger reaction. I don't know that it was any different than the small reaction, just a little bit bigger. So that's pretty cool. Both our hypotheses were wrong. I thought that the oil and water would mix together. They didn't. They separated. And then I thought that the vinegar and oil were going to sit on top of each other and not mix. And I was wrong there. They had a reaction. So in conclusion, I wasn't right on the hypothesis, but that's okay. And we've completed our first experiment. We'll do another one here in a second. Brittany, are there any questions? And I'm sorry if I cut you off earlier.
Oh no, you're totally good. Nope, they're just following along and giving their hypothesis as you are. I asked in the comments for each of the experiments today, write down your hypothesis in the comments so we can see.
Yes, please. I'd love to read over those a little bit later after this is all done. So now that we've gotten through that, does anyone have any other questions? I think we're good to go and start the second one. Brittany, is that right?
Yep, go for it.
Excellent. Okay, so our second experiment, which is H on our requirements, we're going to explore properties of motion on a playground. Now, obviously, there's no playground here at home, but we do have something similar. So we're going to use a paper towel roll for our slide. So we would see how the weight of a person is affects how fast they slide down the slide. So we're going to use a paper towel roll, just the same, and we're going to do a fair test. So we're going to make sure that everything's the same. I have already set up the experiment place, and we'll run the experiment, but how we're going to test different things, we're going to test different weights and sizes. So I have 5 quarter coins, I have a quarter, I have a token, I have a nickel, a dime, and a penny. So I'm going to go ahead and grab those and show you all that. So we're going to switch cameras here. Okay. So, as you can see, we have this would be a paper towel roll. I actually have a poster roll, so it's a little bit bigger. Might give us a little bit better of an experiment. As you can see here, I have my 5 coins. I have my quarter. I have the token, which is here. I have my nickel. I have a dime. And my penny. So very cool. We're going to be seeing which one can go down the fastest and go the furthest. I guess it's not so much about speed as it is distance. We're going to be marking the distance of each of these as we go. So I'm going to grab a pen to make sure I can mark this distance. And we're going to test each one as it goes down. I think we'll run through it twice. So go ahead and write down what you think is going to happen. I think, so for my hypothesis, I believe that the biggest coin is going to go down the furthest. I think it's going to go and end up somewhere down here in the second piece of paper. So we'll see. I'm going to mark each coin as I go. So I will put the pen down here, and then I'll move the coin after I've done. So first, we're going to go ahead and grab our quarter, and we're just going to put it in the end and let it slide down. Okay. So we're going to mark the back end of the coin and write a Q. So that's the first coin. Make sure that you're writing down or commenting which coin you think is going to win. I think the quarter is going to go the farthest. But so far, I don't think that's as far as I thought it'd go.
We have an agreement for it with you there. Trisha says the larger, the farther. Okay,
well, let's test it. Let's see if that's true. Maybe the nickel will go farther because it's denser. But now we're going to have the token, which is a little bit thinner than the quarter, but a little bit smaller too. So we'll see. Let it go. Okay, not quite as far. So we're always marking the back end. So that's the token. So not quite as far. Let's go with our nickel next. So, okay. Put it in the back and let it go. Oh, wow. Not nearly as far. Okay. So that's our nickel. We're going to do our penny after that. Okay, penny is definitely farther than our nickel. And then finally, we're gonna go with our dime, the smallest of the coins. And we'll see how far that one goes. Wow. I'm sorry that I might not have caught all that, but the dime went the furthest.
Ooh.
So, once again, so far, it seems like my hypothesis is not quite right. So let's test it again and see if maybe it was just a fluke. We'll do 2 run-throughs. Everything will be the same. So this is the quarter again. Okay, similar. So that's our second quarter. Next, we're going to do our token. Okay. After that, we'll do our nickel. The nickel went farther this time. Do our penny next. Okay. Penny is about the same spot. And last, we're going to do the dime again and see if the dime wins. And the dime by a good amount. I think the dime is our definite winner. And I think some of our hypotheses were wrong, but that's okay. That's what we're doing these experiments for. Definitely something cool to test, and we see something different. So I think that's going to conclude our test of the coins. So I'm going to bring it back to Brittany.
I have a question. Can you go and close up on the results of all the coins so we can see?
Absolutely. Yes.
Awesome.
Nickel, nickel, penny, penny, token, token, quarter, quarter, dime, dime. So we're pretty close. We're not exact with all these, but they're in the same range for all of them. So definitely similar results, and the dime definitely blew past all the other coins. So that was pretty surprising.
Perfect.
Okay.
Well, awesome. It looks like we had quite some say the smaller the farther. A couple of hypotheses.
Hypotheses.
Yeah, hypotheses. Yeah.
It's one of those. But yeah, that definitely makes sense. It could have been a lot of different things. So that's cool that we got the opportunity. And it very well might be different than if we would have done it with a slide and people. Might have slid differently depending on how tall they were, how much they weighed. A lot of things could have been affected by this. So really cool to see. I want to thank everybody again for coming and joining us. We're going to do a quick recap before we leave. I will go through. Anna, do you want to read through what the FAIR test was, or do you want me to?
I can read through.
Okay.
So a FAIR test is a test that controls all but one variable when attempting to answer a scientific question. Only changing one variable allows a person conducting the test to know that no other variable has been affected for the rest of the test.
Absolutely. And that leads to our scientific method, which is how we were testing everything. We had a question. We researched and looked into it. We created a hypothesis. We thought up what might happen. We did our experiment, which was the fun part that we did today. We got all the data and analyzed it and what happened. And then we came up with a conclusion. So what changed at the end? So Anna, can you just reiterate a little bit on what your projects were?
My projects were talking about the different types of soils and the effect it has on plant growth.
Okay.
So we have our constant with the potting soil, because we know that it'll grow in that. And then we have our dirt that we just found outside, sand, and rocks. And our hypothesis is that the potting soil will grow the best, and that these ones, it'll grow differently. And then with our other experiment with our soap and water to view the results. So this was our constant, just dish soap and water. This was our dish soap, water, and dirt. You can see most of it has completely settled to the bottom. There's still a little bit floating on top with some suds, but even the dirt line has settled to the bottom, which is really cool to look at. It's actually really, really cool to look at. Next up is our salt. It's still really murky, but what I think is kind of cool is that you have clear right here, and then the dirt kind of rose to the top. So if we're taking a bath with like the bath Epsom salts, that's probably why we get a ring around the tub, because all of the little dirt floats to the top where the big dirt settles to the bottom. So I think that's really cool.
Interesting.
And then last but not least is our laundry soap. It's still floating down. It's still floating down, but even the dirt line has settled some, and it looks like it's separating. There's like soap particles in there, but you can see the soap particles are staying still, but the pepper or dirt particles are all sinking to the bottom. So I think that's really cool.
I bet you if you waited longer, you'd see even more out of those.
Yeah, I'll let it sit for a little bit, and I'll take a picture and post it in the comments so everyone can see after a little bit what it ended up looking like in, say, an hour-ish time.
Excellent. So just to reiterate what my experiments were. So we saw our two, oil and water. Both are exactly the same. They're going to be separate. The oil is floating on top of the water. We did those the same. As you can see, our reactions have finished for our vinegar. That's a little messy, but both of them had quite a bit of it bubbled up, and it was exciting to see. It was a good time, similar to a science fair volcano, putting those in with food coloring. And then our last experiment was the 5 coins, seeing which one went the furthest, and the dime surprisingly won. So that was really interesting. I'm glad that we had the opportunity. I want to thank everyone for coming, and we want to remind you that tomorrow there is going to be a Lion's Den meeting. So feel free to have your younger siblings come and attend.
Trophy.